Okay, hi everyone, welcome to this video series on introductions to firewalls. So this is just a quick picture I want to show here of a few computers connected here to our switch and our server. So chapter 4, understanding firewall basics. The primary function of a firewall is clear: to protect the internal network from the hostile outside network known as the internet. Because you want to communicate on the internet, the firewall should allow some traffic to pass while blocking unwanted traffic. However, you may want users to initiate communication with your network, so the firewall should let in some outside network traffic. In this chapter, you'll look at some advanced functions of firewalls that can be used to further define a firewall's inspection possibilities, optimize its performance, and even alert you to suspicious network traffic patterns. Not all firewalls have these advanced functions. Some support only limited versions of these functions, and some even use different names for these functions. Using different names makes it hard to determine what a particular firewall can and cannot do. Luckily, an organization called the ICSA conducts a certification process for firewall products, making internal servers available. Static address mapping. The actual IP address of an internet accessible server on a firewall protected private network is not known to the outside world. Users on the outside know only the public firewall IP address. Configuring static address mappings on the firewall allows access attempts to the public firewall IP address to be directed to the internal server. Static address mappings can also be used for outbound network traffic. In this case, you want the NAT component of the firewall, the function of the firewall that replaces or translates private IP addresses on the internal network to public IP addresses when connecting to the internet. Always to use the same public IP address for connections from a particular computer on the internal network to the internet. When we described NAT for outbound internet traffic in chapter 3, we assumed that the NAT component of the firewall would automatically use the firewall's own external IP address and dynamically select an available source port to use. For example, if a computer with an IP address of 10.1.65.2 on the internal network wants to connect to a server with IP address 39.4.18.13 on the internet, the firewall with an external IP address 23.1.4.10 will dynamically create the address mapping similar to the example shown in table 4.1. In this example, port 43.05 is chosen by the internal computer, whereas port 6004 is chosen by the firewall. Network traffic returning from the external server and arriving at firewall port 6004 is sent back to the original sender 10.1.65.2. This dynamic address mapping is done only when the internal computer actually makes a connection to the internet. After the connection is finished, the mapping will be removed by NAT. However, there are two situations where the NAT address mappings should be less dynamic. Static IP address assignment. If your internet service provider has provided you with multiple public IP addresses for use on the firewall, you can assign specific public IP addresses to certain private IP addresses for computers on the internal network. This static address mapping can be used for both outbound and inbound network traffic. Static inbound translation. When you want to make a server with a private IP address available to connections from users on the internet, you have to tell the firewall to forward certain inbound ports on the public IP address of the firewall to the server on the internal network. This is also called port forwarding or server publishing. Static IP address assignment. Your ISP may provide you with a range of IP addresses such as 23.1.4.8 through 23.1.4.15. You can assign all 8 of these IP addresses to the external network card of the firewall without static address assignment. The NAT component can just use the first external IP address 23.1.4.8 as the source IP address for all internet requests from all computers on the internal network. Because port numbers range from 1 to 65535, the firewall has thousands of ports available as translated source ports, so it can easily handle all internal computers with just one public outside IP address. However, you may have applications running on the internal computers that require a distinct public IP address to be used for internet connections. An example of such an application is an internet game that may require different IP addresses for different game players, or for logging purposes, you may want certain internal computers always to use the same public IP address when connecting to the internet. In those situations, you have to configure the firewall to use a specific IP address such as 23.1.4.12 for all the outbound internet requests made by a specific computer on the internal network. Note that the outside world can never see the internal computer's own IP address such as 10.1.65.7, but always see it use 23.1.4.12. Other computers on the internal network use one of the other public IP addresses when connecting to the internet. In this example, the NAT component on the firewall contains the static address mapping that is shown in table 4.2. The asterisk or star in the table stands for any port number or IP address. Static IP address mapping can be used for outbound network traffic initiated by internal computer 10.1.65.7, or it can be set up to allow inbound network traffic initiated on the internet. In that case, network traffic for all ports on 23.1.4.12 are forwarded to 10.1.65.7. Note that normal packet filters are still used to determine which ports are actually forwarded to the internal computer. Static inbound translation. Instead of statically mapping all ports of a specific public IP address to an internal private IP address, most firewalls also allow you to specify that only specific ports from the public IP address should be mapped to the internal private IP address. This is commonly referred to as port forwarding or server publishing, as shown in figure 4.1. You can see here. Because only a specific port is mapped to an internal IP address, the same public IP address can be used either to offer several different services on several different internal servers by using different port forwarding rules on the same IP address. Table 4.3 shows an example that forwards inbound traffic to port 80 HTTP protocol, port 25 SNMP protocol, and port 119 NNTP news protocol to different internal servers. Note that the static address mappings in table 4.3 describe only the inbound mapping of a particular port on the public IP address of the firewall 23.1.4.12 80 to a port on the server on the internal network 10.1.65.10:80. When a computer on the internal when a computer on the internet actually makes a connection to access the server, NAT adds the dynamic mapping to correctly return the network traffic to the computer on the internet. Some firewalls allow you to map a port, for example 8030, on the public IP address of the firewall to a different port on the internal server, which allows for secret ports to your internal server. For example, you can select outside customers that to test your new website, they can connect to www.dummies.com 8030. The static mapping on the firewall can be set up to forward network traffic on port 8030 to an internal web server, which most likely uses a standard port 80 or standard HTTP port 80. Static address mappings that are used to allow inbound network traffic can be combined with additional rules at the firewall to further restrict which traffic is allowed in. Filtering content. Application proxies can inspect the entire application data portion of an IP packet, unlike packet filters, which can look only at the header of a packet. The application proxy service must understand the application protocol used. However, using an application proxy service allows you to create much more extensive rules on what network traffic is acceptable or not acceptable at the firewalls. Many firewalls support these kinds of extended rules. Some example rules are given in Table 4.4. The first rule blocks HTTP video content that is obtained from the MTV website. The second rule blocks downloaded information that contains the word whereas or the word files. The weird spellings are here explained in the hackers or SPAC sidebar. The last rule blocks all email that appears to come from an email address that has sent unsolicited spam style email. Table 4.4 expresses the extended filtering capabilities as one-line filter rules. Because of the complexity of the filtering combinations and their dependency on specific application protocol options, most firewall products display a special application-specific representation of these rules instead of the one-line style used in Table 4.4. Firewalls may be able to filter based on the following application-specific aspects. HTTP content type. Even though network traffic on port 80 HTTP may be allowed, you can restrict the list of acceptable content types. Examples of content that you may want to disallow are video files or audio files. File names. The firewall can block certain files from entering the internal network. Of course, this filter is useful only if the file is not renamed to something else. File content /virus. A filter may be able to inspect the contents of files that are downloaded. Objectionable content may be blocked. The most useful example is the detection of viruses in those files. Keywords. Certain keywords can be placed on a block list. Packets that contain keywords from the block list are disallowed. SNMP email inspection. Besides the scanning of viruses or keywords on the block list, special email filters may disallow certain attachments or deny certain sender domains or addresses. FTP get put SNMP get /set. Application protocols may be filtered to allow only read actions and block write operations. Examples are restrictions on the file transfer protocol FTP or the simple network management protocol SNMP. Site name /site address. Packet filters are already capable of determining the external source IP address or the external IP address or the external destination IP address. This functionality may be extended by specifying a filter that restricts access based on a site's DNS name, such as www.bad.com. The advantage of this approach, besides improved readability, is that the filter blocks network traffic to all IP addresses that the name resolves to, and a site's name may resolve to 2 or more IP addresses. Note, however, that a firewall may not endlessly match names to IP addresses back and forth. If you have a rule that disallows access to the web destination 197.2.3.66, the firewall may notice that 197.1.7.13 actually refers to the same website. Time of day. Rules can be expressed that include the time of day, which allows different restrictions for daytime, nighttime, and weekends, for example, username. Instead of defining rules that apply to everyone, filters may be restricted to apply only to certain users or groups of users. Of course, this restriction requires that the firewall be able to authenticate the user who is making the internet request. The firewall may have a special rule that applies to unauthenticated users or anonymous connection attempts. Connection quota, data quota, filtering options that are based on a cumulative previous internet connections are much harder to implement. An example is a filter that limits data transfer through the firewall to a maximum of 1000 MB per user per month. This filter requires the firewall to collect and remember information per user over time and must include mechanisms for coordinating the information if multiple firewalls are used for the same purpose. Detection intrusion. Filtering packets and inspecting the application portion of an IP packet may do an adequate job in deciding which network traffic should be allowed in and which should not. However, modern firewalls are capable of taking a more active role. The firewall can monitor the packets arriving at the firewall and analyze them for signs of security problems, sort of like a burglar alarm for your firewall. This is called an intrusion detection system. Just analyzing the packets at the firewall for a telltale signs of intrusion attempts is not enough, of course. Intrusion detection systems must also include a reporting or alerting mechanisms. You may even have a firewall page you at 2 a.m. to alert you that an incident is in progress. In this section, we will look at the analysis that a firewall may perform to detect an intrusion and if an actual intrusion is detected, how the system should respond. Finally, we discuss how firewall administrators should react when an intrusion is reported. So I'm going to leave it here today for this video. Thank you for listening and have a nice day.